Okay, so here's two more problems from chapter 23. The first one is number 39 about back EMF. So we have a motor, epsilon, that produces 120 volts and it draws 10 ampere. Actually, this is a mistake in the text, but it doesn't really matter. Is 20 ampere is the current that goes through this loop, to this circuit. So the motor, 120 volts, draw 120 amps into this circuit. And the question is, what is the resistance of this motor nominally? So in order to solve this problem, we just apply Ohm's law. So the resistance, R, is 120 volts divided by 20 amp, give you 6 ohms. Now we know that as soon as we turn on the motor, there is a back EMF. Therefore, the amount of current actually circulate into this circuit is less than this 20 amps. Now, in order to do that and to solve problem number 2, which asks you what is the current that this motor draws when you have 100 volts back EMF. Here's the E epsilon B back EMF 100 volts, which I put over here with the symbol of the back EMF. So the current in this case is going to be I, but this time we're going to apply Ohm's law, considering that we have both a source of 120 volts and then we have a back EMF of 100 volts. So the total voltage is 120 minus 100 volts divided by the resistance. We know what that is, 6 ohms. And so the amount of current that actually goes into this motor is only 3.33 amps. Just applying Ohm's law, considering that we know what the back EMF is. Okay, so that is for problem number 39. For problem number 44, which is on the right here, we have essentially a transformer. And the transformer looks like this, where you have two coils. We have one coil on the left, which is the primary, which we have a voltage epsilon 1 and a number of turn in this coil N1. And then on the other side, where your appliance is attached, in this case, this is a video game system, we know that epsilon 2 is 9 volts. We know that the epsilon 1, which is the current, the voltage that comes into your transformer, is 120 volts. We know that the number of turn in the first coil, the primary, is 400. And we know that your video game system requires a current I2 of 1.3 amps. So the first question is, how many turns are in its secondary coil in this configuration? Well, the number of turns in the second coil is equal to the number of turns in the primary times V2 over V1, which is the secondary over the primary. So you plug in the number, you have 30 turns. The second question is, what is the input current when the output is 1.3 amps? So we have the 1.3 amps as an output on the secondary. So what is the input on the primary? So I1 is equal to I2 times the ratio of the secondary, the number of turn in the secondary divided by the number of turns in the primary. And so you have 1.3 amps times 30 over 400, and they'll give you much smaller current, 9.75 times 10 to the minus 2 amps.